Hi folks, today we're going to talk about how to divide polynomials using long division. So long division is something that you learn in elementary school. Some of you might still remember it, some of you might not, but we're going to practice today with kind of a normal long division problem, so something with just numbers, and then we're going to practice with polynomial long division. Now at this point, hopefully you've watched together in class the song about dividing polynomials, and so we're going to reference that in just a moment. But before we start, I'd like to go ahead and I'm going to skip these things right now because we're just going to kind of review. This is a review from elementary school. So you can see a division problem either written like this with a little fraction bar, which is why it belongs in the rational unit because it is a fraction. So you can see division as either having a fraction bar or you can see it written like this. Either one of those means division, to divide. So what I'm going to do is I'm going to put this top part inside of the division, what some people call the division house, so 3,251. And then this bottom part, what you're dividing by, that goes outside. So when doing long division, you want to see how many times 14 will fit into 3. Well, it doesn't fit into 3, so you go to 32. 14 goes into 32 2 times. And what you just did there was division. You tried to see how many groups of 14 32 could be split into, and it can be split into 2 groups. There's some left over, but that's okay. The next step is to take 2 and 14 and multiply them. 2 times 14 is 28. So multiply. And then with 32 and 28, I want to subtract. And then now that I have the 4, I'd like to start the process over again, but 14 doesn't go into 4, so I bring down the 5. So I bring down. So 14 goes into 45 3 times. I put my 3 up here. That was my division. 3 times 14 is 42. That's my multiplication. I subtract these two numbers. I get 3, and I bring down a 1. Now I start the process over again. So 14 goes into 31 2 times. I multiply 2 times 14. That's 28. I subtract 31 minus 28, and I get 3. And there's nothing else to bring down, so this is my remainder, and I write it over what I was dividing by. So this answer is 232 and 3/14. This would be my answer. So I'll go ahead and box that down here. 232 and 3/14. So that's how you write your remainder. Sometimes you see like remainder 3 like that, but we don't want to write it like that. We actually want to include it as part of the answer, so we make it a fraction. We put the remainder over what we were dividing by. So in polynomial long division, the setup is the same. So I'm going to take the first thing, and I'm going to put it inside of the kind of polynomial division house. X squared plus 4x minus 22. And I'm putting what I'm dividing by outside. Now, when you're doing polynomial long division, you can't divide anything by x minus 3 just by looking at it. So what you do is you just consider the first terms. So x squared and x. Well, how many times how many times, but what is x squared divided by x? The answer is x, and I'm going to put it on top of the x term. I'd like to keep my exponents the same in a column. So if I divide x squared by x, I get x. Now, I have to multiply x by x and get x squared. But I also here need to multiply x by negative 3 and get negative 3x. I want to subtract, but I don't just want to subtract the first term. I want to subtract the whole thing. So that means that I'm going to give the subtraction here, and I'm also going to give it here, which will change this sign. So x squared minus x squared cancels out, and 4x plus 3x equals 7x. So I've divided, I've multiplied with distribution, I've subtracted both terms, and now I need to bring down my minus 22. And I start the process over again, only thinking about the first terms. So if 7x divided by x is 7, a positive 7, I multiply. 7 times x is 7x. And I don't have anything here, but that's because I need to multiply 7 times negative 3, which is negative 21. I'm going to subtract these terms, but I need to subtract both of them. So subtraction, subtraction. Subtracting a negative makes it addition. Keep that in mind. 7x minus 7x is 0. Negative 21 plus 21 is negative 1. And I would write my remainder the same way as before. I'd put my remainder over what I was dividing by, which was x minus 3. So my answer is x plus 7 minus 1 over x minus 3. This is my quotient, my answer to the division problem. So I'd like to go back up to the top just to fill in a couple of the steps. Because when you're dividing polynomials with long division, make sure that all powers are represented. And it talked about that in the video. For example, if we went straight from an x squared term and we didn't have this and we went right to the minus 22, we would have to insert 0x in here. Because I need to go from x to the power of 2 to a term with x to the power of 1 to a term with x to the power of 0, which is just 1. We know that from our exponent rules. So make sure that all powers are represented, and if you don't have a power represented, add on a 0x to the power of whatever's missing. Put that in its place. Also remember that when subtracting two terms, like here, subtracting x squared and minus 3x, you must change the signs of both terms, because you have to distribute the negative. Okay, so let's move on to our second page. Now the next part is dividing by a monomial. It says divide each term in the numerator by the monomial in the denominator. Do not use long division. So let's talk about the difference in this problem and the previous problem. The previous problem was dividing by x minus 3. This is a binomial because it has two terms separated by a plus or minus sign. So this is a binomial you're dividing by, and you use long division. But here, I have a large polynomial, and I'm just dividing by one single term. This is a monomial. Mono, the prefix, means one. And I know it's a monomial because it doesn't have any addition or subtraction, so it's just a single term. So the way that you deal with this is not long division. The way that you deal with this is creating separate fractions with the monomial as the denominator, and then simplifying as you go. So my first term in the numerator is 24, let's do this in a different color, and I'll highlight the stuff in pink. 24 x to the power of 5, y to the power of 7 over my monomial, 4x squared y cubed. My next term has a plus sign, and then the next term in the numerator is 16x cubed times y to the power of 4 over my monomial, 4x squared y cubed. Next term in the numerator, minus 4x squared y cubed over the monomial, 4x squared y cubed. That's interesting. Last one, minus the term 2xy over my monomial, 4x squared y cubed. Remember that we're writing this differently because no long division is necessary. I'm not dividing by a binomial, so I don't need to do the polynomial long division. I just need to kind of simplify each of these fractions. So when I do this, I have 24 divided by 4. What is that? 6. I have x to the power of 5 over x squared. Do you remember how to deal with those? When you have x to the power of 5 over x to the power of 2, the way you deal with this is subtraction of the exponents. And this is an exponent rule that we learned about earlier in the year. And the reason that x to the power of 3 would be my answer when I divide those two is because if I rewrite this, if I kind of expand it, so 5x's over 2x's, x and x cancel out, and x and x cancel out. And what's left over is this. So what we've done is we've done subtraction. So keep that in mind whenever you're simplifying each of your fractions here. So this is x to the power of 3, y to the power of 7 minus 3, which is 4, plus our next term. 16 divided by 4 is 4. X cubed over x squared is x to the power of 3 minus 2, which is 1. I don't even need to write it. And then y to the power of 4 divided by y to the power of 3 is y to the power of 4 minus 3, which is 1 again, and I don't need to write it. Next term, I'd like for you to try out the last two. So pause your video and try to simplify the last two terms. So back when we were writing this third term, we noticed that the numerator and the denominator are the same. So how many times does something go into itself? Well, it goes in one time. And you can see that because 4 over 4 becomes 1. And x squared over x squared becomes 1. And y cubed over y cubed becomes 1. So this term is just a 1. It's not 0. It is still there, but it is a 1. And then this last term is a little strange because the 2 over 4 simplifies to 1 over 2, so that's still a fraction. X on top and x squared on bottom means that there's an x left over on the bottom. And y on top and y cubed on bottom means that there is a y squared left on the bottom. This is like 1 minus 3, which is negative 2, and that means it ends up down here. So this would be my final answer. So that's what it looks like when you're dividing by a monomial. So we kind of sidestepped a little bit. We're going to come back to dividing by a binomial. When you're dividing by a binomial, remember to use long division and check that all powers are represented. Put a 0 term in if you need it. So I'm going to draw my division house. I'm going to put my numerator in there. If you are familiar with the phrase top in, bottom out when you're dividing, that's what we're doing. 3x cubed. Next thing I need is an x squared term, and I have it. Next thing I need is an x term. I have it. And then a constant term. I have it. And I'm dividing by x plus 2. So I'm going to show the steps out to the side. Divide, multiply, subtract, bring down. Remember that we're only considering the first terms in the polynomials. So 3x cubed divided by x. 3x cubed divided by x. Well, you still have a 3. And x cubed divided by x, if you take one of them out, you have x squared. So I'm going to put that on top of my x squared term. 3x squared. I just like my exponents to be the same in the column. Next step is to multiply. 3x squared times x is 3x cubed. And 3x squared times 2 is 6x squared. Notice that the first term is the same as the term that's right above it. You want it that way, because what happens when you subtract both terms? Change the signs. 3x cubed minus 3x cubed is 0. 4x squared minus 6x squared is negative 2x squared. Notice that we have x squared, x squared, x squared, x squared. So if you forget it here, this is kind of a reminder that this is the type of term it should be. And finally, we bring down our next term. And we're ready to start the process over again. Negative 2x squared divided by x. Well, the negative 2 stays, and x squared divided by x is just x. So that goes up top. Notice that I have the same terms in the column. Next step is to multiply. Negative 2x times x is negative 2x squared. Negative 2x times 2 is negative 4x. I want to do the subtraction, so I'm going to subtract both terms. I need to change both signs. Subtracting a negative becomes plus. Subtracting a negative becomes plus. Negative 2x squared plus 2x squared is 0. Negative 5x plus 4x is negative 1x. Bring down. And we're ready to start over again. Negative x divided by x is negative 1. So that's going to go up top. I do my multiplication. Negative 1 times x is negative 1x. Negative 1 times 2 is negative 2. Something that helps people remember how to subtract here is to draw the line, change both signs. So every time we draw the line, change both signs, draw the line, change both signs. So that might help you remember. Negative x plus x is 0. Negative 3 plus 2 is negative 1. So that's my remainder. I subtract 1 over what I'm dividing by, x plus 2. So my final answer for this problem is 3x squared minus 2x minus 1 over x plus 2. This is my quotient. So let's go to number 3. Number 3, I'm going to help you set up, and then I'm going to see if you can, try it on your own, and then check back. So on number 3, top and bottom out, draw my little division house. I have 4x cubed. Next term should be an x squared, and it is. Next term should be an x. Do we have one of those? No, so here we need to add in a 0 term, a 0x term, and then plus the constant. And we're dividing by x minus 1. So here you might want to put a little arrow, missing x term. Insert, sorry about that, insert 0x. So in your notes you might want to have that little caption there. Okay, so what I'd like for you to do is pause your video, try to do polynomial long division with the steps. So multiply, divide, multiply, subtract, and bring down. Remember that you divide only with the first terms. Okay, so pause your video and try it out. So hopefully you were able to at least do the first round. So divide, multiply, subtract, bring down. I have the answer up on top for you, and I'm going to reveal line by line the work. So to divide, 4x cubed divided by x, I have that here. It's 4x squared, so that's what came here. You multiply 4x squared times x and 4x squared times negative 1. You subtract, so you draw the line, change both signs. So you end up with 2x squared. And then you bring down that next term. And you start over. So we divided, we multiplied, we subtracted, we brought down. Now we divide again with first terms. 2x squared divided by x is 2x. I write that here. I multiply. 2x times x is x squared. 2x times negative 1 is minus 2x. I subtract, so I draw the line, I change both signs. 0x plus 2x is 2x, and I bring down my next term, my plus 1. And I'm ready to start over again. Last cycle, 2x divided by x is 2, so I put a plus 2. I multiply, 2 times x is 2x, 2 times negative 1 is negative 2. I subtract, I draw the line, change both signs. 1 plus 2 is 3, and that's my remainder, so I write it as plus 3 over x plus 1, which I get from right here. So my answer is 4x squared plus 2x plus 2 plus 3 over x minus 1. That is my quotient. Okay, last question. We're going to do this one together. So top in, bottom out. Make sure we're looking for missing exponents. So we start out with 4x to the power of 5. That means our next one needs to be a 4 or an x to the power of 4 term. But it's not, so we're missing one. Plus 0x to the power of 4. We need to put that in there. Now we need an x to the power of 3 and an x to the power of 2. We don't have it, so we're going to put a 0 term in. Then an x term, then a constant term, and finally what we're dividing by. So notice that under our division sign, we have a power of 5, 4, 3, 2, 1, and 0, because there are no x's that show up there. So let's try this out, and I'm not going to do it in different colors. I'm going to do it just in one color so that we can see what it actually looks like. To divide, multiply, subtract, and bring down. So 4x to the power of 5 divided by 2x. 4 over 2 is 2. X to the 5th power divided by x is x to the 4th power, so I'll write that on top. Notice how if we would have skipped this term and gone right to this, we wouldn't have had a lined up exponent. So now I multiply 2x to the 4th times 2x. 2 times 2 is 4. X to the 4th times x is x to the 5th. And 2x to the 4th times 1 is the same thing, 2x to the 4th. I draw the line, I change both signs. 4x to the 5th minus 4x to the 5th goes away. 0x to the 4th minus 2x to the 4th is negative 2x to the 4th. And I bring down plus 7x cubed. And I start the process over with my first term. Negative 2x to the 4th divided by 2x. The 2's cancel out, but you still have the negative. And then x cubed. So minus 1x cubed. I multiply. Negative x cubed times 2x is negative 2x to the 4th. And negative x cubed times 1 is negative x cubed. Subtract. Draw the line. Change both signs. Negative 2x to the 4th plus 2x to the 4th is 0. 7x cubed plus another x cubed is 8x cubed. And I bring down the next term. And I'm ready to start over with my first term again. 8x cubed divided by 2x. 8 divided by 2 is 4. X cubed divided by x is x squared. Notice that every time I put a new part of my answer, I put it in there with its sign. So if it's positive, I put plus. If it's negative, I put minus. So we divide it. We multiply. 4x squared times 2x is 8x cubed. And 4x squared times 1 is 4x squared. Subtract. Draw the line. Change both signs. 8x cubed minus 8x cubed is 0. 0x squared minus 4x squared is negative 4x squared. Bring down the next term. And we start over. It's a long problem, but if you get into a habit of following this rhythm of divide, multiply, subtract, bring down, it's much, much easier. So negative 2x, negative 2x. Negative 2x times 2x is negative 4x squared. Negative 2x times 1 is minus 2x. Draw the line, change both signs. Negative 4x squared plus 4x squared is 0. 2x plus 2x is 4x. Bring down my last term, almost done. Divide. 4x over 2x is just 2. 2 times 2x, and 2 times 1. Draw the line, change both signs. 4x minus 4x is 0. 1 minus 2 is negative 1, and there's nothing left to bring down, so I write my remainder as minus 1 over 2x plus 1. So I'm just going to go ahead and leave that here. I can box it like this, but I don't have space to rewrite it. So that's how you divide binomials with long division. We follow the same pattern every time. It's a cycle, just like regular long division. You divide, multiply, subtract, bring down until you can't do it anymore. The only trick is you have to make sure that wherever you have a missing exponent, you put in a 0 term. And then whenever you subtract, make sure you subtract both signs. So change the sign on each term.